Alright, on to your last video for the week. So we have 10.3, how to use chords to solve some problems here. So this will be the chords we talked about. Chords are simply segments with endpoints on the circle. And we'll learn all kinds of chord facts, or chord theorems, if you will. And those theorems are going to help us develop relationships within circles that will help us solve problems. So we're going to have, I think, 4 or 5 different chord facts. It looks like I have 3 only, maybe 3. Okay, changes every year. So, first one I found important was that congruent chords have congruent arcs. Okay, the reasoning for this is very, very simple. So we'll talk about this for a second. So what this says is that if FG and JH are congruent chords, those lines are congruent, then those arcs are congruent. And I'm actually going to show you why. If I took and I drew in this little tiny dotted line here, and this dotted line here, and this dotted line here, and this dotted line here, right? Certainly, these two sides are the same, right? These are all radii, and so all of those sides are the same. So I can mark those like this, put 2 for all of them. At this point, we have 2 triangles that are the exact same. Okay, those triangles are congruent triangles because these are vertical angles. Now, what you can do is well, not necessarily vertical, but they're definitely congruent because these are SSS congruents. Okay, so if these sides are the same, then these angles are certainly the same, whatever they happen to be. Now we get the fact that if these central angles are the same, then those arcs are the same. Okay, that's all it is. So if it's true that FG and JH are the same, then we get the fact that arc FG is congruent to arc JH. Okay? If those chords are the same, then the arcs are the same, and vice versa. Alright, under number 2, I'll spare you the proof of the rest of these. Okay? Congruent chords are equidistant from the center. So, if these chords happen to be congruent, or if they happen to be the same distance away, so we'll put this, that means that those lengths are the same. So if it's true that FG and JH are congruent chords, then we know that XL, okay, XL is that piece right there, that's going to be congruent to LY, okay? Or if XL and LY are the same, then the chords are the same, okay? So this means implies. And that always makes a right angle. So we have all kinds of opportunities to answer questions about that. You can always use the fact that, this is a right angle, it creates a right triangle. We've done all kinds of stuff with that. Okay, and on to the last one. It says number 3, a diameter that is perpendicular to chords, so to a chord. It bisects both the chord and its arc. So if this is indeed, if AB is a diameter, then it cuts in half XY and arc XY. Okay, so this is the same, and I'll actually mark the arc as well. Those are the same. So if AB and XY are perpendicular, then we know that XZ is congruent to ZY. It's cut in half. And XB, the arc, is congruent to BY, the arc. Okay? That diameter cuts that chord in half. Okay, assuming that it's perpendicular. So those are the 3 different chord facts we're going to use. Let's do some examples with them. So, for example number 1, we're going to round if we have to. They're going to be kind of nasty, some of them, I think. Find the value of x. So what different things could we have here? So notice, we have 109 degrees and 109 degrees to start off the bat. If these 2 arcs are the same, looking at chord fact number 1, if we have congruent arcs, we have congruent chords. Or if we have congruent chords, we have congruent arcs. So the fact that those 2 arcs are the same, can't get this paper off. The fact that these 2 arcs are the same tells us that these 2 chords are actually the same as well. So we need only to set them equal to one another. So we do 3x plus 2 is equal to 5x minus 7. Solve it. Get 2x over here, 9 here. X is 2/9. Is it 2.222 repeating? Yeah. 0.2. Okay. Pretty simple, right? Use chord fact number 1. So here, look at number 2. It's kind of a cool problem, right? We have x degrees here and 70 here. It looks nothing like any of the chord facts that we have. But remember, the first chord fact says if we have congruent chords, then the arcs are the same. So if these two chords are the same, then certainly this arc is also x. And now we actually have the entire circle built up of arcs, right? And the arc measure of the whole circle always adds up to 360. So we can do x plus 70 is equal to 360. So we get 2x is equal to 290. X is equal to, was that 145? 145. Okay, pretty simple. On to number 3. In circle A, the radius is 14, CD is 22, and the measure of the arc CB, this should say measure out front, okay, is 27 degrees. Find CEBD and DCB as an arc. So, first off, we have a situation where we have a radius, or a diameter if we were to extend it, right? And it's perpendicular to a chord. So we are actually on chord fact number 2. Congruent chords are equidistant from the center. So these right here, oh sorry, we're on chord fact number 3. The diameter cuts these two pieces in half. So that chord is going to be cut in half, and that arc is going to be cut in half. Okay, we're using chord fact number 3. Sorry about that. So if the radius is 14, then we know first off that this is cut in half and that's cut in half. So does that tell us anything? We have CB as 27 degrees, and so certainly BD, measure of arc BD, is going to be the same. That's also going to be 27 degrees. So that one's done right away. Okay? And now, if CD is 22, remember, it's cut in half, which means that each half of this is going to be 11. So it tells us right away that CE, which is this half over here, is going to be 11. So that one's easy too. And the last one we have is DCB, DCB. They want us to go all the way around here. Now, not too terribly challenging, right? If you look at the measure of arc DCB, it's actually everything except for this tiny piece right here. It's all around the outside of the circle except for this little chunk. So what we would do is we take 360 minus the 27, and we get what, 333? Make sure I'm right, yeah. 333 degrees, okay? Those aren't too bad. Okay, all it uses the fact that this radius or the diameter cutting that chord in half gives us that we have bisected chords and bisected arcs. That's all it does. And the last one, I think we're going to use all 3 here. We'll find out. We have, in the circle, we have this crazy circle with stuff going on. HQ, this piece over here, that is 48. Let's put 48 in there. 48 degrees. HI is congruent to JK. So these two chords are congruent. And JR is this piece right here. That is 7.5. Okay? So find each measure. So let's go ahead and talk through this for a second. If these two chords are congruent, we know the two arcs are congruent. Okay, that's step 1. That is going to be chord fact number 1. Now, chord fact number 3 says that if this radius, or the diameter, remember we can extend this, intersects this chord perpendicularly, then these are cut in half. So this is 48, and this is 48, which means this whole thing is 96. Okay, put that on there, 96. But we know that these arcs, since the chords are the same by chord fact number 1, these arcs are going to be the exact same over here. So this is 48 as well, and so is this. Okay, that's kind of step number 1. Now, we know from chord fact number 2 that if these chords are congruent, then they are the same distance from the center. So this distance and this distance are the exact same. Okay, so we're going to need to do some work to find that. But so far, we have a pretty easy setup. So let's answer whatever questions we can, and we'll go back and see if we can get some solutions. Remember, this is 7.5, this is also 7.5, and so are these, because they're equal or congruent. Okay? So HI is going to be right here. Well, that's 7.5 plus 7.5. I believe that's 15. So that's the arc though. Arc HI. So even easier. So remember that this whole thing right here is 15. Arc HI is just the 48 plus the 48. So we'd get 96 degrees. Okay. Arc QI. QI is right here. That's half of that whole thing. So that's just 48 degrees. So far, so good. Arc JK, well, that was congruent to arc HI, so that is also 96. Now, this right here is the length of line segment HI. We'd add that already, so we got 15. Okay, again, after you do the whole circle, it's very easy to fill these out. PI. PI is just this little half. That's 7.5. That was congruent to the other one because of the fact that the chords are congruent. And the last one is JK. JK is simply 7.5 plus 7.5, so we get 15 again. No sweat for us. Okay? If this is challenging for you, that's okay. There's a lot of stuff going on. It's kind of confusing looking at this circle, but overall, once you get started, just like before, once you get started and get some stuff kind of figured out, it gets kind of easy. Alright, we have one more example, then we're done for the week. We have number 5, example number 5. So we have this nice circle here. The circle is named circle O. The radius is 32. That will be important. Okay? Notice how we don't actually have a line drawn there. PQ and RS are the exact same arcs. I'm going to mark those like this. I'm going to mark them. And PQ, this line, is 56. So let's talk about some stuff. So from chord fact number 1, if these arcs are the same, then those chords are the same. So we know that PQ and RS are actually the same length. So more importantly, from chord fact number, what is it, number 3? Number 3, if this is a radius, which we could draw, kind of extend it, right? And it intersects this chord perpendicularly and cuts it in half. So we know that these guys right here are cut in half and they're congruent. And it says that PQ was 56. So that means that each one of those things is going to be 28. So I'm going to put that in there. 28 and 28, 28 and 28. And remember, this will cut in half. Okay? So we have that. And remember that means that the entire arc length, this thing right here, is going to be the same as this chord, so it's going to be 56. So far, so good. Now, it's going to ask us to find OB eventually, and so I want to draw your attention to this little triangle I'll draw right now. See how I drew a triangle right here? I'm going to outline that. Asking us to find OB is going to be simple because we're simply going to find the length of this guy right here. Okay, and we actually know what OQ is. Okay, OQ is 32 because it says the radius of the circle is 32, and this is a radius I've drawn, right? There's a bunch of them. So this will be a right triangle problem. So let's see what we can answer first and come back if we need to. PB, well, that's 28, already written down there. Easy. BQ, again, that's 28. Also quite easy. OB is going to take some work. How about RS? Is RS going to take work? No. RS is simple, right? Here's R, here's S, so the whole thing is 56. So the only one that requires any effort is OB. I will draw that triangle again right here just so you can see it. But we have O, B, and Q. This was 32 because it's a radius. This was 28 from the problem. And we want OB. So simply a Pythagorean theorem problem. This right here is the right angle, so you would go x squared plus 28 squared is equal to 32 squared. These are some big numbers. 28 squared, what is that? 28 squared is 784. And 32 squared is 1024. Go ahead and subtract. You get 240. Square root both sides. Remember, we don't want the negative because we're in geometry. Got to break 240 up into a perfect square times something. I don't know the largest perfect square that goes into 240. Let's go with... well, we know that 8 goes into it. What is that's not a perfect square, though. How about 4? What is 4? 60. And 60 breaks into 15 and 4. So we should be able to put 16 into 240. Unless I'm thinking wrong. Yeah. We can go root 16, root 15, right? 16 times 15 is 240. A little bit of mental math there. Do that at your own speed, whatever you're going to do. Okay? And now the root 16 is just 4, root 15, and that would be our final answer. Okay? So OB would be 4 radical 15. Nothing crazy happened there. If you got this far, I'm quite happy, and if you wanted to put the decimal in there, that's good to go. This isn't our focus. But up to here should be completely reasonable. Okay? And that would be like one of the most challenging questions that I'd give you in this section. And that finishes 10.3, and therefore finishes week 4. Hope you had a very good week. Have a good rest of your day as well.